Hey everyone, welcome back to the character customization series in Unreal Engine 5.6. Today we're creating the variables and maps that power our outfit system, adding a clear function so clothes don't stack, and wiring our UI buttons so players can swap outfits smoothly in real time. By the end, you'll have a clean, professional base for character customization. All right, so now we're inside our third-person character blueprint, and this is where I'm going to start creating some variables. Why here? Well, the third-person character is basically the brain of our player character. It's where all the logic for movement, cameras, and interactions lives. So it makes perfect sense to also store our customization data here. Things like which clothes are showing, which materials we're applying, and which slots we need to override. Now, let's pause for a second and talk about what a variable actually is. Think of a variable like a little storage box with a label on it. You put information inside the box, and later you can pull it out whenever you need it. In game development, variables are everywhere. Health, score, ammo, level progress, they're all stored in variables. For our system, variables will keep track of which slots belong to which clothing categories and what materials we can swap in. But here's the catch. One slot is rarely enough. Your character doesn't just have one mesh for clothes. It might have multiple dresses, multiple tops, several shoes, and more. That's where arrays come in. An array is like a shopping list. Instead of holding just one item, it can hold many of the same type. So here we're going to create 9 variables for our customization system. The first one is a material instance variable, and this one is special. It's of type name and map. Why a map? Because we want to link a slot name to the material that should go on it. Think of it like a dictionary. The slot is the word, and the material is the meaning. That way, Unreal always knows which material belongs to which slot. The other variables, like dress slots to override, top slots to override, bottom slots to override, shoe slots to override, armac slots to override, tail slots to override, ear slots to override, and glasses slots to override. These are all arrays. Why arrays instead of maps? Because each category can have multiple slots inside the skeletal mesh. For example, a character might have 3 different shoe meshes or 2 different tops. Instead of making a separate variable for each one, we just keep them all together in a list. That's the array. Then, whenever the player clicks on an option in the UI, we can loop through that array and apply changes to every slot in that category. So, in short, map variable, material instances, equals link slot names to materials, like a dictionary. Array variables, slots to override, equals store multiple slots for each clothing category, like a shopping list. This setup makes our system both organized and scalable. Easy to manage now, and easy to expand later when we add more outfits or accessories. All right, let's start with our very first variable, the material instance map. Go ahead and add a map element to it. Now, open up the sk_lily skeleton and copy the material slot ID. You could rename the slot IDs if you want to keep things cleaner, but in my case, I'll just use them as they are. The only small change I make is deleting the word instance from the names. That way, they won't accidentally override each other and things stay a bit more organized. And one important note here, guys, make sure every slot has a unique ID. If 2 slots share the same ID, Unreal might get confused and override the wrong one, so always double-check your naming. Once you've got the slot ID copied, paste it into the variable we just created, and that links it directly to the material instance we want to assign. So now that we've given our slot ID, we also need to assign the material instance that goes with it. Basically, for every slot ID we add into this map, we pair it with the exact material we want applied there. Why do we do this? Because the slot ID tells Unreal where the material should go, and the material instance tells it what should actually appear. If we only gave the ID without the material, nothing would change visually. And if we only gave the material without the ID, Unreal wouldn't know which slot to apply it to. By pairing them together in this map variable, we're essentially building a little instruction list. Slot 01, red dress material. Slot 02, blue jeans material. Slot 03, leather shoes material. And what happens when we do this? Later, when the player clicks a button in the customization UI, Unreal can just look up that slot ID in the map, find the material we assigned to it, and apply it instantly. No confusion, no guesswork. Everything is organized and automatic. This is what makes our system flexible and scalable. If you want to add 10 more outfits later, you don't need to rewrite code. You just drop new entries into this map, and Unreal already knows how to handle them. All right, we're done with the Material Instance map, so let's move to Dress Slots to Override. What is it? Dress Slots to Override is an array of slot IDs for every dress mesh/material slot on our character. In simple words, it's a list of all the dress-related slots we might want to change at runtime. Why do we create this variable? Because a character can have multiple dress slots. Dress 01, Dress 02, trim, belt, etc. If we only stored a single slot, we'd miss the rest. With an array, we can batch update all dress parts at once, show, hide, swap, loop through every slot cleanly, no copy-paste nodes for each slot. Scale later, just add new dress slots to the list, no logic rewrite. Why an array and not a map? Array equals a set of targets, which slots to act on. Map equals a lookup table, slot arrow specific material to apply. We already used a map for this slot gets that material instance. We use arrays for these are all the dress slots we need to touch together. Both work together. The array tells us where to act. The map tells us what to apply. What to add here? Open sk_lily, or your character mesh. Look at the materials list and collect every slot ID related to dresses. For example, dress_01, dress_02, dress_trim, etc. Add each of those slot IDs into dress slots to override, as name or string depending on your setup. Stay consistent with how you keyed your map. Bonus best practices. Keep slot IDs unique and consistently named. If you add a new dress mesh later, just append its slot ID to this array. No logic changes needed. If some dress pieces share a material, they can still live as separate slots. The loop handles them all. Now let's quickly mirror this pattern for the rest of the categories. Top slots to override, all top-related slot IDs. Bottom slots to override. Arm axe slots to override. Shoe slots to override. Tail slots to override. Ear slots to override. Glasses slots to override. Each one is an array for batch operations on that category. This is what makes your customization system modular, clean, and production-ready. All right, let's create a new function here and call it material_from_map. Why do we need this? Because instead of writing the same find material and set it on slots logic over and over, we'll keep it all in one clean place. Anytime the player picks an outfit, we'll just call this function and it will handle everything. Look up the right material and apply it to the right slots automatically. Adding the inputs. Now let's set up our inputs. Item ID. Set the type to name. This is basically the unique identifier for the item or outfit we want to apply. It's like the key you'll use to look up the material. Material map. Set the type to map, where the key is a name and the value is a material instance. This map is our dictionary. It links an ID to the exact material instance we want to apply. So for example, dress_red could point to m_dress_red_inst. Slots to override. Set the type to name array. This is a list of all the material slots on the character that we want to change when this item is selected. Think of it like saying, these are the slots that belong to dresses. Update all of them at once. Building the logic. Now let's build the function itself. Drag in the material map input and add a find node. Plug the item ID into the find name pin. This will search the map and try to get the material instance that matches the given ID. Add a branch node. The branch checks if the material was actually found in the map. If true, we have a valid material to use. If false, the ID wasn't found, so we'll use our base mat to hide or clear that slot instead. Drag out the slots to override input and add a for each loop node. This loop will go through every slot name we passed in, so we can update all those slots one by one without copy-pasting nodes. From the loop body, if the branch says true, material found, call setMaterial by name. Target, the mesh, your character's skeletal mesh. Material slot name, the current array element from the loop. Material, the material we got from the find node. If the branch says false, no material found, call setMaterial by name again, but use base_mat.
This way, if we don't have a custom material for that item, we just make the slot invisible or clear. Why this is important. This single function does all the heavy lifting. The map lets us quickly look up the right material using just an ID. The array means we can handle as many slots as we need in one go. The branch makes it safe. If something's missing, we fall back to our base mat instead of breaking the system. See this not equal check here? This one is really important for keeping our outfit swaps clean. Here's the problem it solves. Imagine the player is already wearing the red dress. Now they click on the pink dress. If we just blindly add the pink dress material on top without first clearing the red one, the character ends up looking like they're wearing both dresses at the same time, layered and messy. That's not what we want. So what we do is simple. First, we check. Is the current slot's item ID not equal to the new item ID the player picked? If it's not equal, meaning the new item is different, we first set the material to /base_mat to clear the old dress. Then we apply the new material for the new item. This way, when the player switches from red dress to pink dress, the red is fully removed first and only the pink is visible. No stacking, no weird overlap. The character always looks clean and only shows the chosen outfit. Open WP_character_C. In the graph, use the event construct node. Right after setShowMouseCursor equals true, add getPlayerCharacter not controller, cast to BP, third-person character, or your character BP. Promote the cast result to a variable and name it BP_character. This avoids having to do getPlayerCharacter plus cast every time a button is clicked. Clean and efficient. Now let's wire up the dress button. We're inside our widget graph, WP_character_C. On the dress button, I've added the OnClicked event. From here, we use the BP_character variable. This is the reference we created earlier when we casted to our BP_third-person character. Instead of calling getPlayerCharacter to cast every single time a button is clicked, we keep this reference once and reuse it. Next, we drag out from BP character and pull in the variables we already set up. Material map, the map that links each item ID to its correct material instance. Dress slots to override, the array of slot names where the dress material should be applied. Then recall the function material_from_map and connect everything. Target arrow BP_character item ID arrow the ID of the dress we want to equip. For now, you can just type it. For example, the material slot name such as dress_pink_01. Material map 2, the material map variable on the character. Slots to override 2, the dress slots array. What happens when you click the button? The item ID you passed is sent to our material_from_map function. The function looks up that ID in the material map and finds the correct material instance. It loops through every slot in dress slots to override and applies the new material. Thanks to the not equal check we added earlier, it first clears out any previous dress. So if the player was wearing a red dress and clicks a pink one, the red dress is removed before the pink is applied. No more weird overlapping outfits. Now let's add the rest of the dresses. Repeat the exact same setup for every other dress option you want to include. Select the Next Dress button in your UI. Go to its OnClicked event. From the BP_character variable, plug in the same material map, your dress material map. dress slots to override, arrow right, your dress slots array. Call material from map again. Set the item ID to match that dress, e.g. dress_blue_01, dress_green_02, etc. Now let's test it out. Hit play and try clicking on the dress buttons in the UI. You'll see. Every time we click a different dress, the outfit actually changes in real time. The previous dress gets cleared first and only the new one appears. Pretty cool, right? Let's wire the tops button, same as we did for dress. Copy-paste the dress logic. In WP_character_C, select the dress button's OnClicked graph. Copy it and paste under the top buttons OnClicked. Update just two things. Item ID change to your top's ID, for example, top_black_01. Slots to override switch from dress slots to override to top slots to override. Test hit play. Click a dress, then click a top. You'll notice the top appears over the dress. They're stacking. That's expected right now because we haven't cleared the dress slots first. Let's fix the overlap with a clear function. Create clear in BP third-person character. Open BP third-person character, add a new function and name it clear or clear slots. Add an input called array of type name and array. This will hold the slot IDs you want to clear. Inside the function, use a for each loop on the array. For each element, use set material by name. Set the target to mesh, the material slot name to the array element, and the material to clear material. Set clear material's default value to base mat. This way, every slot you pass in will be reset to the base material so nothing stacks or overlaps. Use clear before applying tops in WP_character_C. Go to the top button's OnClicked event. From BP character, call clear and pass dress slots to override to remove any dress first. Test your setup. Play the game, pick a dress, and then click a top. The dress clears first, then the top appears with no overlap. If you click the same top again, the not equal check prevents it from reapplying. And if you switch to another top, it swaps cleanly. Apply the same logic to all categories. For dress OnClicked, clear top slots to override first, then call material_from map for the dress. For top OnClicked, clear dress slots to override first, then call material_from map for the top. For bottoms, clear any conflicting dress. The simple rule is, always clear the conflicting categories slots with clear first, then call material_from map to equip the new item. Do this for each category. Copy the working OnClicked logic from any button. Change item ID to the correct ID for that category. Example, bottom black 01, shoes white 02, glasses round 01. Change slots to override to that category's array. Example, bottom slots to override, shoes slots to override, glasses slots to override. Remember the clear step to prevent overlap. Bottoms button. Call clear on dress slots to override first, then call material_from map for bottoms. Dress button. Call clear on top slots to override first, then apply the dress. Tops button. Call clear on dress slots to override first, then apply the top. Quick test routine. Play, click through each category, confirm only the chosen item shows, no stacking. Clean swaps when changing items in the same category. Note for you guys. For now, we're keeping it simple by typing the item ID manually as a name when we connect the button. That's the fastest way to show the system working. But don't worry, in the next step, we'll upgrade this by using an enum instead of manually typing names. That way, the whole setup becomes much more scalable and easier to manage when you add lots of outfits or want to refactor later. Enum keep your IDs consistent and save you from typos, so we'll switch to that soon. Quick personal reason I love enums, they turn chaos into calm. Years ago, I had a dropdown of 20 string IDs. One typo and nothing worked. Enums said, nope, pick one from the list, and my bug rate dropped instantly. Next episode, we'll switch to enums, so your system scales without becoming spaghetti. I'd love to hear your tiny win in the comments. Did you create your own category, maybe necklace or socks, and hook it up to swap like we did today? If you did, I'm cheering for you. You're doing amazing. Please share it so I can celebrate with you. And if not yet, no worries. Give it a try. I know you can do this. I'm showing you every single category, not skipping any steps. Why? Because I know when you actually see 3 or 4 full examples, it clicks so much better. If I only showed one and said, just repeat it, you'd probably still have questions. So we're going through each one together to make sure you really understand how to build the whole system. Since we're doing the same setup for all categories, don't zone out, try this with me. Pause, wire one button, test it, then come back. Tiny wins count. And here's a quick tip. If something doesn't show, double-check the slot name. Make sure it's in the array and confirm the item ID matches the map key. Also, tell me your next category idea. Necklace, cape, socks, and I might feature it next episode. You've got this! You know, while we're wiring up all these categories the same way, dress, top, bottoms, shoes, let me tell you a little story. When I first built a customization system like this, I thought I was being super smart and skipped the boring repeat steps. I said, I'll just wing it later. Spoiler, future me was not impressed. My character ended up wearing a dress, a top, and somehow 3 pairs of shoes at once. Looked like a fashion disaster. That's why I'm walking you through every single category now. Repetition might feel slow, but it's what makes your system rock solid. Every slot you add and every clear you wire in is one less weird double shirt bug you'll have to hunt at midnight later. So trust me, this is the good kind of boring. Okay, now let's test and play. Looks like everything's working. Pretty awesome. Next video, we'll add the color sliders to bring the customization to life. If this helped, please like the video and subscribe so you don't miss the next part. And drop your questions or tiny wins in the comments. See you in the next one. Bye guys, take care.